Hi, this is Joyce Farrell. Let's take a first look at a simple computer program. Some basic programming operations occur in almost every computer program. First, there's input. A user puts some data into a program, some facts and figures. Input devices that are used include keyboards and mice. Sometimes input data comes on a disk. Audio data might come through a microphone. After the data is input, it's processed. The piece of hardware that performs processing is the central processing unit, or the CPU. Processing might include doing some arithmetic, or sorting the data, or organizing it in some way. After data is input and processed, you can output the information that you've created. Output is available for a user to see the results of the program. Output devices include monitors and printers. Audio output might come through speakers, or sometimes output is sent to a disk, and then that disk might be used as input into a new program. When programmers plan the logic for their programs, they tend to use one of two tools. Flowcharts are pictorial representations of the logical steps in a program, and pseudocode is the logical steps of a program written out in English form. Here's the logic for a program that adds 1 to a user's input number. On the left is the flowchart of the program, on the top right is the pseudocode, and on the bottom right is what the program might look like after it's been written and it's running in a command prompt window. In both the flowchart and pseudocode, the first step is to start. In the command prompt window, you might type a command to run the program. The command will differ in every programming language that you use. This program happens to have been written in Java, so the command is Java and then one more, which is the name of the program. In both the flowchart and the pseudocode, the next step is to input the user's entry. In a real program, you might add an output statement before input user's entry to explain to the user what to do. In this very simple example, on the output screen we'll just have a question mark asking the user for an entry. And then the user types in some data. Let's say 16. The next step in both the flowchart and the pseudocode sets a spot in memory called result to user's entry plus 1. Nothing happens on the screen during this step. This processing happens in the central processing unit and in memory. So result becomes 1 more than the user's entry. The next step in both the flowchart and the pseudocode is to output the words 1 more than, followed by the user's entry, followed by the word is, and ending in result. On the screen it says 1 more than 16 is 17, because 17 is the value of result. And then the program ends. You can run the program again. Start it, give the command to start it, ask for input, perhaps the user types 345. In memory, result is set to 346, but you don't see anything happen on the screen yet. When both the flowchart and the pseudocode get to the output statement, then on the screen you see 1 more than 345 is 346. And both the flowchart and pseudocode stop. You don't have to run programs in a command line environment. Some programs are created to run in a GUI environment. GUI means graphical user interface. For example, suppose you have the GUI screen that you see in the lower right part of the screen. In the flowchart and the pseudocode, you still start the program. You still input the user's entry. Let's say the user types 67 into a text box. In memory, the result becomes user's entry plus 1. You don't see anything happen on the screen. In both the flowchart and the pseudocode, the next step is to output 1 more than user's entry is result. And on the GUI screen you can see 1 more than 67 is 68. The flowchart and pseudocode for the GUI program are identical to what they were for the command line program. The logic is the same no matter what the environment is. Thanks for watching.